Alright, hell yeah. So we have linear algebra, and what we're going to go over is a system of three equations that have a lot of solutions. So it has an infinite amount of solutions. And so what does that mean? I think the easiest thing to do is just take one equation, and let's say we have 2x plus y is equal to 6. Cool. So let's say I threw a 1 right in here for x. I would have 2. What would I have to add to get to 6? I would have to add 4. Okay, so hell yeah. So that means that x equals 1 and y equals 4. This is a solution. Now let's say I said x was 2. And then I would have 4 here. 4 plus what is equal to 6? This is 2. So now I have a solution that x is 2, y is 2. And with one equation, where I have two unknowns, you know what I mean? If I wanted to get a very specific solution, I can't, because like all of these, there's an infinite amount of numbers that I could put in here to satisfy this equation. That's where in physics problems and math problems, you would have to come in with like an x minus y is equal to 1, and now we have something here. You know what I mean? We could probably have a solution to this. But there's a chance that, this, if I get this to the other side, this is y is equal to negative 2x plus 6. This is going to be a line with a slope of negative 2 going through 6. And so we're going to have like a slope like that, kind of a steep negative slope. This one, let's get the y to this side. This is going to have, and this is going to be x minus 1 is equal to y. That's going to be a y-intercept of negative 1 and a slope of 1. So heck yeah, right there you're going to have a definite solution. So if you have two equations where these lines are parallel, like had this line been like this, just with a different y-intercept, those two lines would never cross and you would have no solutions. If those two lines are just on top of each other, and one way we can do that is just take this equation and say it's 4x plus 2y is equal to 12. That line is going to be just this line again. And then so those two lines are going to overtop each other, and then you're going to have an infinite amount of solutions. Yeah, that got me confused for a second, but hell yeah. So we started with this line initially, and then we had this equation that's this line. That has one unique solution. Then we said that we could have an equation that has the same slope, but just a different y-intercept. That equation, that I don't have written, but we could write it, has those two equations don't have any common solutions. So that's the deal. That's where I got confused, because if I have this line, an equation for it, still any x value that I have corresponds to a y value, and so I would have an infinite amount of x values and y values that would correspond to each other. But if I'm saying two equations, I want the solution to two equations. I want to throw an x value and a y value that satisfy both of those equations. Can I do it? And in this case I can, and we get that unique solution. But if I had this equation and this equation, there would be no x and y that satisfies both of those. So it would have no solution. And then we came up with the idea that if I have this line and then I just doubled this equation, hey, I have, that's an equation of a new line, but it just overtops this line. And so those two equations are going to have an infinite amount of x's and y's that satisfy both of those two equations. So I think the confusion for me was just starting with one equation, but that's not a bad place to, that's why I wanted to start with this. It's just like if you have one equation, it seems like you can't find a solution, and from physics and math you're just like, well, don't I need another equation? Well, if you're trying to find something very specific, but if I have one equation with two unknowns, it just means that I can put an infinite amount of numbers in here, and then it's going to give me an infinite amount of, so I'm going to have an infinite amount of x1, y1 to x infinity, y infinity. I don't know if you'd write it like that, but every corresponding x is going to have a corresponding y to get this value of 6. Alright, hell yeah. So, booyah. So for these three equations, we do have that. We're going to get an infinite amount of solutions. There's not just one particular solution. And with three equations, we have planes that come together. And so you can have planes, you know, kind of, three planes can come together and only have one solution. So that's cool. You could have two planes come together like this. And those two planes are going to have an infinite amount of solutions. And then if you had a third equation, maybe coming in like this, then those are going to have, bummer. I forget from the book. But anyway, the whole idea from this one is just to run through the numbers and do the, using Gaussian elimination, we're going to get these as our answers. So we're going to turn this into an augmented matrix. We take the coefficients, we have x, y, z, and all we're interested in is this coefficient 1, 1, negative 1, 1, 2, 1, 3, 3, negative 3. And then we're going to have on this side 2, 4, 6. So the augmented matrix looks like this. 1, 1, negative 1, and then 2. 1, 2, 1, 4, 3, 3, negative 3, 6. And then we're going to draw a line right here. And so we know that these are x, y, and z, and if I was to multiply this matrix, let's say this was matrix A, by this vector of coefficients, so we would have something like matrix A, and then multiplied by vector x is equal to matrix B, where this matrix X is x, y, z in a vertical format, and then you would multiply this by that. Cool. But again, all we wanted to do for this video is just to go through how to use Gaussian elimination to get these to be zeros, you know, probably this one to be 0, to get this, you know, value of z to be equal to some sort of number, let's say. Okay, sweet. And I think it's kind of difficult to do this process without, you know, like having your numbers overlap or not wanting to write this thing 1,000 times. So I'm going to see that this is a 3 down here, and I want to get rid of this 3. So I'm going to multiply this one. I like to do it by multiplying it by a negative. I want this to be negative 3, so I'm going to multiply this whole equation by negative 3. So this becomes negative 3, negative 3, positive 3, negative 6. So that's all I did there. And now I'm going to add these two equations. And when I do, these 3's are going to cancel. I'm going to have negative 3 plus 3. Those cancel. And then I'm going to have negative 3, positive 3 minus 3. This cancels. And then I'm going to have negative 6 plus 6. That goes to 0. So what we have found right here is that for our z value, and honestly, like the way they do it in the book is like, you know, start, if you are going to have infinite solutions, is to represent your z value as any number. But I think you could do it also from this perspective. You could probably start over here and represent your x value as any sort of number. Because look at this. So z is going to be any number. That's what t represents. It's just any number. And then you see that, well, this is just 3 times t. So there's no difference than calling this value. Let's say you called this value w. Let's say x was equal to w. Well, then z is just 1/3 w. Because if z is 1/3 w, then x is 3 times that. You know what I mean? So I could have started with this being my, and you could even do it with the y value. So if you get something like 0, 0, 0, 0, this means that one of the, that you're going to get an infinite solution. Now if this was 0, 0, 0, 2, then no solution. You know what I mean? Then you can just move on that there's no solution. Alright, hell yeah. So this right here represents that we can represent z as any number, and we use this letter t. You know what I mean? Let's go L, M, N, O, P, Q, R, S, T. And then, so what they're going to, well, S, T. No, I think it's rhyme or reason. You know, I don't. Well, no, there probably is a rhyme or reason. Typically, they're going to represent the first value for any number as t, and then the second value is s, and maybe they move on to r, q, p. It's always good to know in these textbooks why you represent this as t. You could represent it as any letter you want, but they get into the idea of representing this as t, and if another value, like y, can be any sort of number that's different than z, then you can represent y as equal to s. But in this case, our problem, y isn't any number, and it has to be 2 minus 2t, and x has to be 3 times t. So that's what we have here. So cool, we know that z is now t, and that totally gets, this column is totally known now. And so now we have, let's say, these two equations, where, you know, maybe we want to whittle it down to a y value, so we want to get rid of these two. And again, what I'm going to do, you know, just to make my life not miserable, is I'm going to have this be a -1 and this be a +1, and I'm going to add the equations. Now, in the textbook, they do subtracting the equations, but I just think I'm going to make a whole lot more errors. So I'm going to take this to -1, -1, +1, and then -2. And I could have easily done that just by putting a negative, made this a positive negative. But alright, hell yeah. Now I'm going to add these two equations. We're going to get 0, 1, adding them, so 2, adding them 2. So let me double check, hell yeah. And then we have this. So we already know what z is, and this says that 1y. So if we write this equation out, it says 1y plus 2z is equal to 2. So let's solve for y. So y is going to be 2 minus 2z, and we're basically done. And z is t. So there you go. Y is equal to 2 minus 2t. And then another way to do that is just to already know that z is t, so we can say that this y is going to be 2 minus 2t, and that's y. If this was a 3 here, we would have to say 2 minus 2t, all divided by 3, and that's y. But this value is already represented as 1. Alright, booyah. So we have y is 2 minus 2t. Cool. And then, and we don't have to do anything more, you know what I mean? Because we have in this equation or this equation, we now know z, we now know y, and we just need to know x. And so let's just use this equation. So x is going to be 2, so x is equal to 2 minus, and I would say a negative, getting this to the other side, a -1z, and then minus a 1y. So this is going to be a 2 plus z minus y, and we're going to have 2 plus t, and then a minus y. Sometimes it's better to do this as a side. If I'm factoring through a -1 on both sides, you're basically foiling this through. This becomes -2, positive 2t, and then you can rearrange 2t minus 2. But hell yeah, if I'm factoring through, multiplying both sides by a negative y is just 2t minus 2. These just switch places. Hell yeah. Okay, so now I have 2 plus z, that's 2 plus t, and then this minus y is just that. So I'm going to add 2t minus 2. This is going to be just 3t. These 2's cancel, and I get 3t. And there you go. So this is going to have infinite amount of solutions. I can choose any value for z. Let's choose the simplest, and let's choose z to be 0. I mean, yeah, z is 0, and this t value is 0. So now I'm going to have x is 0, y is 2, and z is 0. And let's see if that satisfies. 0, 0, y is 2. Cool. 0, 0, y is 4. Cool. And then 0, 0, and then y is 2, so that's 6. Hell yeah. Let's try t is equal to 1, and then kind of be done with this video. So that's going to be so we have z is equal to 1. Y would be equal to 2 minus 2. Y would be equal. Alright, hell yeah. Sorry about that. Ran out of juice. So we're going to say z, or t, the t value, we're just going to say any number is 1. Cool. So x becomes 3, y becomes 0, and z becomes 1. And now we're going to plug that into here. So we're going to have 3 plus 0 minus 1. That's going to be 2. We're going to have 3 plus 0 plus 1. That's going to be 3 plus 1 is 4. And we're going to have 3 times 3 is 9 plus 0 minus 3. 9 minus 3 is 6. Cool, let's just do one more just so we're, let's choose t is equal to 2. So we have x, y, z. This is going to be 2 minus 4. So that one is going to be negative 2. 2 times 3 is 6. And then we have value of 2. So now we're going to have 6 minus 2. That's going to be 4. Minus 2 is 2. We're going to have 6. And this is going to be minus 4. So it's going to be 2. Plus 2 is 4. We're going to have 18 minus 6. So that's going to be 12. Minus 6. That's going to be 6. Alright, so hell yeah. So things check out. And this is just a way to represent an infinite amount of solutions. You can choose any number for t, but your y value is going to be a function of t, and x is a function of t. So again, in some of these, you can choose any y value and maybe any z value. Maybe z is equal to t, and then any y value. Y is equal to s. And then x might be maybe like 2s minus t or something like that, where you can choose any, like y and z can be any values. And that's how we kind of started the video, is if we have an equation that's just like 2x plus y is equal to 6, then any value that I choose for x has a corresponding y value. So in this case, I could see x is equal to t, and then y is just, some function of t, something plus t or minus t. And the reverse can be true. I can say this y can be any number t, and then this x is going to be something plus or minus t. Alright, hell yeah. So that's good enough for this video, and we're going to do some more of these, so hell yeah.